Okay, this video begins homework 3, and what we're going to do is talk about different multiplication models that we have. And the first one we're going to talk about is the repeated add-in model. I can't tell you how astonished I was when I first began teaching to see that a student might look at 6 times 5 as 5 plus 5 plus 5 plus 5 plus 5. Oops, one more here. Okay, so then I could go 5, 10, 15, 20, 25, 30. Or typically the way you see students do on paper, 5 and 5 is 10, 5 and 5 is 10, 5 and 5 is 10, for a total of 30. But anyway we go about it, we're talking about repeated add-ins. Now, fluency is a really important concept in mathematics. Okay, it's important. Fluency means doing lots of things. So it's important that we do lots of single-digit multiplication, because the more we do, the better we get at it. Now, when I went to school, we memorized multiplication tables. Now, obviously, that's not the best way to learn how to do multiplication, but memorizing or being able to do lots of facts builds a mathematical power that will serve you very well, or serve your students well in later mathematics classes, particularly in algebra. One thing that we need to think about, you'll hear people talk about the fact, oh, we don't teach facts, we don't teach facts. No, we don't teach facts. We teach the concept of how the fact is arrived at. But then at some point in time, you have to make a connection between the concrete and the abstract to understand that this repeated addition is the same thing as 6 times 5, and 6 times 5 represents a fact, and the answer is 30. Now, fact families are a way that students can build a conceptual understanding of multiplication. For example, let's look at the 5s. 5 times 1, 5 times 2, 5 times 3, 5 times 4, 5 times 5, 5 times 6. So what happens when I look at these fact families? Okay? So it's about more than memorizing that 5 times 1 equals 5. It's about looking at and saying, well, I have 1 5, so that's the same thing as 5. I have 2 of those, so I could do 5 plus 5 and get 10. I have 3 of those, so I could do repeated addition and get 5 plus 5 plus 5, which is 15. 5 times 4, and so forth. So I am learning about fact families, however, I'm not just memorizing facts. So using the repeated addition model, I could look at multiples of anything. 7 times 1, 7 times 2, 7 times 3, 7 times 4. So if I looked at that, I could have 4 7s, and then 7 plus 7 is 14. 7 plus 7 is 14, so I end up with 28. Now notice that I used a double strategy that we learned about in addition when we were talking about that. Now I could have just gone and said 7 plus 7 is 14, 14 plus 7, and continue to go on. Okay, but actually looking at the strategy that I did with the doubles is a much easier concept to look at doing the multiplication. One thing you want to think about that's really important is that as you develop sophistication in math, you learn about which is the most efficient tool to do a process, or which is the most efficient mechanism. In other words, I could count by fives here. Yes, I could do the repeated addition, but it's much easier to look at it as doubles, and then it's an easy addition problem. Okay? Now, let's take a look at and think about the concept of an array or an area model. Okay? An array or an area model is really important to see, and one of the best area models that you can look at would be rows of chairs in a classroom, or eggs in an egg carton, okay, or muffins in a muffin pan. Because we have this idea of what the picture looks like. So if we have one of those 6 muffin pans that looks like this, okay, this is an area model of 2 rows of 3 muffins. Okay, an egg carton okay, we could look at eggs inside these cartons. And this would represent, I could look at it 2 different ways actually. This would represent 2 rows of 6, okay, or 12 eggs. Or it could be 6 columns of 2 eggs for a total still of 12 eggs. Now, in the classroom when you were a young student, how often did your teacher go in and count the chairs in a row? Would probably have actually all of her rows having the same number of chairs. So let's say we have 6 chairs in each row, and I have 5 rows of chairs. Okay, so then I would have 6 times 5 chairs. Or I could count them up and have 30 chairs. Okay, so looking at an area model. Now, an array is just a little bit different. Okay, an array assigns a horizontal and vertical position to a location. Now, I actually would get out and show you a geoboard, but I don't know what I did with my geoboards. Okay, so here I have 4 arrays of 4, and I hate doing that. Let's put another one in here. So then I could look at this as 4 arrays of 5, or I could look the other way and say that it's 5 arrays of 4 for a total of 20 points in the array. Okay? So that's an array model. Okay, another model we have is one that you're familiar with, and I call it Burger King's Have It Your Way. Okay, it's the Cartesian product. Okay, so let's suppose that we can pick one of each of these. We can pick one vegetable, so we've either got lettuce, tomato, onions, or pickles, and we can pick one sauce, mayo, mustard, or ketchup. So if a server at a restaurant actually punched the button for a Whopper with those kinds of things on it, what would the cook see who's actually making the Whopper? Well, let's take a look at it. All right, so first of all, the cook would see, does the person want to order something that's lettuce, tomato, onion, or pickles? And then once I make that choice about what I want, let's say lettuce, then I'm going to compare mayonnaise, mustard, and ketchup to each of those veggies. Okay? So then I would pair tomato with mayo, mustard, and ketchup. I could pair the onion with mayo, mustard, or ketchup. I could pair the pickle with mayo, mustard, or ketchup. Okay, so that the cook then would see here tomato mayo, tomato mustard, tomato ketchup, which gives you 3 more choices here. There would be 3 for lettuce. I have 3 different possibilities for onion. I have 3 different possibilities for pickle, for a total of 12 different possibilities. If I have lettuce, tomato, onion, pickle, and mayonnaise, mustard, and ketchup, and I want one of each. Now, the fundamental counting principle says that I can take 4 items in this, 3 items in this, and I multiply those together, and I get the number of different choices that I have. And it won't be 14, huh? It'd be 12. I don't know why I wrote 14. So I have 12 different choices using the Cartesian product.